There are some core term definitions that are important to understanding the rest of the subject matter at hand. The first of which is the definition of molds, mold making, casts, casting, and cycle. Understanding these specifics now will help inform your absorption of prototyping methods, which in turn inform manufacturing technique. Let's get started. A mold is a three-dimensional negative of your part, sometimes called a die or cavity. The goal of a successful mold is to capture all geometric features of your original part. A mold can be made from many different types of materials, depending on the desired end needs of your components. Mold making is the creation of a mold or negative from your original or master part, capturing dimensional and textural detail for the use of creating reproductions that are identical in form to your original. Mold making takes the majority of your work time for procedural planning after the design of the part. It includes many factors that will affect your production process and is the most meticulous procedure we'll cover in this course. A cast is a three-dimensional copy of your part, a reproduction. A cast can be made from any number of materials chosen specifically for the end use, reflecting the project requirements. The goal of a successful casting is to reproduce all geometric features of the original master part with the added flexibility of different material choices. Casting is a reproduction of your original master part and refers to the process of filling your mold cavity or cavities with material that hardens and is then removed from the mold once cured into a stable state of solidity. In many cases, casting can be repeated multiple times with the same mold. A rule of thumb for ease of prototyping molds is that if your final parts are hard, the mold should have some give. If your end parts are soft, the mold can be hard. Casting involves logistical planning for timing the rhythm of multiple castings. In prototyping, this process involves preparing the material, getting the material in the mold, the curing processing time, the cooling period, removal of the part, and restarting the process. In mass manufacturing, this is generally called a cycle. This cycle is the end-to-end procedure for preparing the material, getting the material in mold, the forming cycle, and the ejection of the part. Factory cycles are much faster than prototyping, but involve a much higher initial cost, which is why full-scale manufacturing is generally reserved for designs that have had most of the bugs worked out prior to the creation of the die for high-volume use. Let's look at those steps now. The first phase is the material preparation phase. The material in storage needs to be converted into usable stock, sometimes by melting it. The second phase is the material placement phase. Once the material is prepared, it has to get into the mold by pouring, placing, or injecting. Once the material is in the mold, the material goes through the hardening phase. The material changes state and solidifies. After the hardening phase, the material still has to cool down so it maintains its new shape. Now that we've reviewed what these core process terms are, we can start diving into the methodology of designing for mold making.